Welcome to NC Engineering and Technology. Our today topic is designing of fire piping using pipe schedule method of NFPA 13 and designing of sprinkler distribution in an specific area. For designing of sprinkler system, we follow two methods. Number one, pipe schedule method, that is easy. It can be performed manually, but its limitation is that we can use this method for a smaller area. For bigger applications, we need to follow the hydraulic calculation method. So today we will study the pipe schedule method. In next study we will cover the hydraulic method. But before starting the designing, we need to understand the important terms used in sprinkler system to understand the subject properly. Why we need the fire protection system design? Because an adequate fire protection design safeguards your building and its occupant. It will protect your health and wealth. What is an sprinkler system? A system consisting of integrated piping network designed according with fire protection engineering standards that includes a water supply source and a water control valve and a water flow alarm and a drain, and commonly activated by heat from a fire and discharging water over a fire area. Automatic sprinkler system design is subject to NFPA 13 standard and equivalent international standard is EN 12845. For our study, we will follow the NFPA 13. What is fire sprinkler or sprinkler head? It is the component of a fire sprinkler system that discharges water when the effect of a fire is detected, such as when a predetermined temperature has been exceeded. This picture is showing an water sprinkler. We will discuss this topic because there are different types of sprinkler and it is a huge topic, so we will discuss it in a separate study. But for brief, you can see this picture. It is the orifice. This is the threaded portion that go inside the fire piping. It is plug and it is sealed liquid filled glass bulb, and there are different color of liquids corresponding to different hazard classes and different temperature. It is the frame and it is the deflector. In ordinary hazard, commonly we use this liquid of red color. The temperature for it is 68 degrees Celsius and 155 degrees Fahrenheit, and our study will be for it today. As I explained you before, there are two methods for sprinkler design. Number one, pipe schedule method. Number two, hydraulic calculation method. What is pipe schedule method? According to NFPA 13, pipe schedule system is defined as a sprinkler system in which the fire pipe sizing is selected from a schedule that is determined by the occupancy classification and in which a given number of sprinklers are allowed to be supplied from a specific size of pipe. In this system, We have pipe schedule in which one side we have the number of sprinklers, on the other side we have the predetermined pipe size, or we have a specific number of sprinkler which can be used up to the specific or predetermined pipe size. Pipe schedule method is used only for light and medium hazard, and it is normally used for small and medium project. In this method, pipe is sized according to system pressure and required flow. In this system, we consider the residual pressure, that is the pressure at the last sprinkler, and sprinkler discharge density and estimated area of coverage determine pipe size. This table from NFPA 13, table number 11.2.2.1. In this one, for the light hazard, we have the residual pressure 15 psi, and we need the water in the reservoir that must be sufficient from 30 to 60 minutes. For the ordinary hazard, the residual pressure is 20 psi, and we need water in the reservoir from 60 to 90 degree 9 minutes, 60 to 90 minutes, and we need a GPM 500 to 750 for light hazard and 850 to 1500 GPM for ordinary hazard. So as we have seen from NFPA table, according to hazard, there is a specific residual pressure and flow and the quantity of water to be reserved. To follow this method, there is some certain points to be remembered. We will discuss one by one. Number one, addition or modification to existing pipe schedule system. That is sized according to the pipe schedule of section 23.5. We can use this method for the addition or modification of existing pipe schedule system or sprinkler system that is designed according to the pipe schedule of section 23.5. Number 2, addition or modification to existing extra hazard pipe schedule system. We can use this method to the existing fire sprinkler system that is designed by schedule for extra hazard. Number 3, new system up to the area of 5000 square feet or less. Number 4, a new system exceeding 5000 square feet where the flow required in table 11.2.2.1 are available at a minimum residual pressure of 50 psi. It means if we need to follow this method beyond 5000 square feet area, then the residual pressure which we have seen before for low hazard it was 15 psi, and for ordinary hazard it was 20 psi. But if we need to exceed the area and we need to use pipe schedule method, then this residual pressure will be go higher, and we need to have it 50 psi. So as I inform you before, if we go beyond to 5000 square feet area and we need to use the pipe schedule method, it is not easy, it became difficult. So it is advised to use hydraulic calculation. But the calculation for pipe schedule method is easy and it can be done manually. So for emergency cases you can use this method for the area exceeding 5000 square feet, but you need to follow the condition. You need the residual pressure 50 psi, that is much higher than the residual pressure up to 5000 square feet. Number 5, for the application having area less than 5000 square feet, this table shall be used in determining the minimum water supply requirement. There is one more important point regarding this using for the use of pipe schedule method. It is acceptable only where the sprinkler system, overflow alarm device and supervisory device are electrically supervised and such supervision is monitored at an approved constantly attended location. It means if we are using fire alarm system with the fire sprinkler system, then we can use pipe schedule method. Now we will discuss the design step using pipe schedule method. First of all, number 1, we need to determine the hazard class of the occupancy. And there are different classes of hazard: light hazard, ordinary hazard, extra hazard and high pile storage hazard. But our method is applicable only for 2 hazard. Number 1, light hazard and ordinary hazard group. For other hazard, extraordinary and higher, we need to follow hydraulic calculation. How to calculate the protection area of the coverage of the sprinkler? So there is one formula to calculate the protection area by one sprinkler. It is equal to A is equal to S into L. S, it is the distance between two sprinklers on the same branch, whereas L is the distance between sprinklers on adjacent branch line, whereas the A is the area of protection of one sprinkler. It is equal to S into L. We can denominate it like this or in this way also, both is same. So for designing by pipe schedule method, first we need to determine the hazard class of the occupancy, and there are different tables for different classes from NFPA 13, which is applicable to us. We have to use this table from NFPA 13. It is for life hazard pipe schedule. So you can see for a steel pipe of schedule 40, we have predetermined number of sprinkler which we can use corresponding to a specific pipe dia. Up to 1 inch we can use 2 sprinkler, and up to 1/4 inch we can use 3 sprinkler, and up to 1.5 inch we can use 5 sprinkler. For 3 inch 60 sprinkler, for 4 inch we need to follow the another section for detail. As you can see, for light hazard there are two tables in which to the corresponding pipe size the number of sprinkler are different. There is one table as we have seen before for the sprinkler either below the ceiling or above the ceiling, all sprinkler at one side. But if we have distribution of the sprinkler mix in one branch, and some sprinkler we have below the false ceiling and some sprinkler we have above the false ceiling, as it is shown here, it is the main, then this branch line is coming from here, so we can see this is our branch line, and we have one sprinkler above the ceiling and another sprinkler below the ceiling. So we have in the same branch line two types of sprinkler, one sprinkler below and another sprinkler above. So in this case we need to follow this table. This table is for below and above ceiling sprinkler, and we can compare the number of sprinkler. For the 1 inch branch line it is same 2 number, but when we go for 1¼ inch we have the number sprinkler lesser when we are using the sprinkler system only below the ceiling, but if it is mixed then we can go up to 4 number of sprinkler. The same way for 1½ in this case this is 5, but in the mixed case it is 7. For 2 inch in below the ceiling only 10 sprinkler but mix 15, and for 2½ inch it is 30 and for another 50. In this case we will study again in detail this. The N sprinkler, one sprinkler we need to use the size 1 inch pipe, but for the another sprinkler we need to use the size 1¼ if we are using 1 inch size for the last sprinkler, for below ceiling 1 inch, so for the last sprinkler above the ceiling we need to use the size 1¼ You can find the detail in NFPA 13 for it. In the same way we have two tables for ordinary hazard, one for the sprinkler located only one side either below or above the ceiling, and in the other there is mixed, some sprinkler in the same branch are above and some sprinkler are below the ceiling. And we can see the same for the pipe size 1 inch there are same number of sprinkler 2 and 2, but when we go for the bigger pipe size the number of sprinkler in the branches that have below and above ceiling sprinkler are higher than the number of sprinkler on the branch that has only above or only below ceiling. For designing purpose you can use this table from NFPA 13 according your case. The second point is determining area coverage and the distance between the sprinklers. There is table for it also, we can find from NFPA 13. You can see this table is for the low hazard, table number 8.6.2.1 from NFPA 13, and you can see this system type. Our pipe schedule method is this. We have two pipe schedule method here, combustible and obstructed. So we have maximum protection area for the pipe schedule method. 200 square feet, and the maximum spacing between two sprinkler is 15 feet. It is for light hazard. In the same way, for medium hazard, we have another table for NFPA 13, and it show the protection area 130 square feet, and the distance between the sprinkler is 15 feet. We will make our exercise based on the medium hazard, so we will follow these values. So the area of protection by one sprinkler we will consider 130 square feet, and the maximum distance between two sprinkler we will take 15 feet. Number 3, determining number of branch line. This branch line, it is not the pipe branch. These are the construction line. It is very important step in this system. We need to make some calculation. So by calculation we will find out the distance between the wall and the sprinkler, and between the sprinkler and sprinkler on the same pipeline, and the distance between sprinkler and sprinkler between on adjacent line. So these value will find by calculation. Then we will draw the construction line on the specific area, and at the intersection of these lines we will find the place where we need to locate our sprinkler. Let us take a sample project. We have one room with dimensions 19.85 meter into 16.7 meter. Let us see how to design the sprinkler system and how to design the pipe sizing for this system as per NFPA 13 using pipe schedule method. As we know, first we need to calculate the area of this room to know if it is coming less than 5000 square feet or more. Which method is applicable for designing the sprinkler system for this room? So let us convert these dimension to the feet, and after conversion these dimension to the feet, we have find the room area 3567 square feet, that is clearly less than 5000 square feet. So we can go for designing using pipe schedule method. Second point, for designing the sprinkler system for this room, we will use the hazard, ordinary hazard, and as per table from NFPA we have these values from ordinary hazard. Maximum spacing between sprinkler is 15 feet, and the protection area by one sprinkler is 130 square feet. So we'll use this value. So we will use this value as per NFPA 13 for the calculation of our project. As per NFPA, for the calculation of the distance, actual distance between the sprinkler and between the wall, there is one procedure. We select one remote area of size 15 square feet, and we make calculation for this remote area to calculate these dimensions. So for the calculation purpose, we will select one remote area inside the room having area equal to 1500 square feet, and we will make calculation for this area to get the required distances for the placement of sprinkler. Then after getting the result, we will generalize it to the whole room. So let us start our calculation. We have assumed a remote area of size 1500 square feet. As we know, the protection area by one sprinkler is 130 square feet. So when we will divide the whole area by 130, we will get the result 11.4, that will give us the total number of sprinkler, and in round we will go to for the 12 number of sprinklers used. So we have calculated the total number of sprinkler that will be used in a remote area which we have selected of area 1500 square feet. Now we'll go for the calculation. Now we'll make the calculation for the length of the remote area. We have one formula for calculation of remote area. S is equal to 1.2 under root square feet of the area. When we apply this value, area value 1500 square feet, we get the result length of the room equal to 46.48 square feet. As we have calculated the value for the length and we have the area, this another the length of this width of the room we can calculate by dividing the total area by one length. We will get the another length. So by dividing 1500 by 46.8 feet, we get the result of 32.27. So we got the both dimension of the remote area, length 46.48 and width 32.27. As we know, the maximum distance between a sprinkler on the same branch or any between two branches also, we can get maximum 15 feet and minimum 6 feet. This table. We will make the construction line in our remote area. Then this generalized equation we will transfer to our main project. You can see this is our remote area, 1500 square feet, and we have calculated the dimension. One dimension is equal to 46.48 square feet and another dimension 32.27. And we already calculated the distance between two sprinklers on the same branch, that is equal to 12 feet, and the distance between sprinklers between adjacent branch, that is 10.83. So let us draw the line, and the distance between the wall and the sprinkler on the same branch will be 6 feet. So we will take first 6 feet. This is the distance between the wall and the sprinkler. Another will be the distance between two sprinkler on the same branch. We will take 12 feet. Again there will be the distance between two sprinkler, again 12 feet. And number 3 also the distance between two sprinkler 12 feet. Again we have the wall, so distance between the wall and the sprinkler is 6 feet. Now we'll go for another side. For this we have calculated the distance between two sprinkler. It is 10.83. So we'll make for it, and there will be the distance between the wall and the sprinkler. It is 5.42. So in this way we have making the straight line, or we have divided this remote area by the lines as per the distance, allowable distance between the sprinkler we have calculated. You can see there are point of intersection between these lines. These point of intersection are the location for the sprinkler which we have to locate. And as we calculated, we need the 12 sprinkler for this room. So let us see this one, one, this 2, this 3, this 4, this 5, this 6, this 7, this 8, this 9, 10, 11, 12. Exactly as per our calculation, we have calculated the number of sprinkler for the remote area 12, and we have placed after the calculation accordingly. And we already suppose that we have these sprinklers on the same line, so let us make the piping up to the last sprinkler, another piping on this sprinkler, and the piping on this sprinkler. These are two sprinkler on the same branch, and we denominate it by S. And these are two adjacent two sprinkler on the adjacent branch, we denominate it by L. Area A equal to S into L. So it is the protection area by one sprinkler. So I think it is clear. For any calculation, before we need to select a remote area of 1500 square feet for low and ordinary hazard. Then we need to make the calculation for the distances between two sprinkler and between the wall, using the protection area for the hazard which we are using. In our case, we are using the ordinary hazard, so the protection area for one sprinkler is 130, and we can select the maximum distance between two sprinkler. It is up to 15 feet. In our case, we select the 12 feet to make the near about square arrangement for the sprinkler. So another dimension we got somewhat 11, so 12 and 11, it is near the square, nearly the square. And now in this way we have completed the study for the remote area, and we have the result. We already find the distance between the sprinkler on and between the sprinkler and between the wall on the same branch, and between the sprinkler and sprinkler on the same branch, and the distance between the sprinkler and the sprinkler on the adjacent branch. These value now we will transfer to our main project. You can see from the remote area we have transferred the same information to our project. We have made the construction lines, and we have mentioned during drawing this construction line we use the distance between two sprinkler on the same branch 12 meter, and the distance between two sprinklers between the adjacent branch .83. By applying this value, we have completed all construction line, and after getting the intersection of these lines, we find the location for the sprinkler. Based on this calculation, we have placed the all sprinkler on the room, and we have drawn the piping between the sprinkler and the main. So for our study, we have to see what is the suitable for you, what is the suitable pipe route for the room we will follow. So in this case, we follow that the main line is coming from here, and the suitable pipe route is will be perpendicular to it. So for this arrangement, we have selected the distance between two sprinkler. .12 feet here, and the distance between sprinkler on adjacent branch, we have to make the arrangement. We suppose the branch line like this, and we take the distance between two sprinkler on the branch line 12 feet, and we have selected the distance between two sprinkler on adjacent line 10.83 like this, and we have completed our distribution of sprinkler with the branch line as per this. Now we will select, or we'll see how to select the pipe sizing according to the sprinkler using ordinary hazard table for NFPA 13. So from the table for ordinary hazard, for 1 inch pipe size we can use 2 sprinklers, and assuming all sprinkler are below the ceiling. So for sprinkler 1 and for sprinkler 2, we have select the pipe size 1 inch and 1 inch. Now we'll go for the sprinkler number 3. We can see for the pipe for number of sprinkler number 3, we need to use the pipe size 1.25 inch. So you can see for the sprinkler number 3, we have used the pipe 1.25 inch. In the same way, for the next pipe size for 1.5 inch, we can use the number of sprinkler 5. Let us see on our drawing. Let us count the number of sprinkler: 1, 2, 3, 4 and 5. So up to 5 sprinkler we can use the pipe size 1.5 inch, and we have selected as per this table. After number 5, we need to go for the next pipe size, and next pipe size is 2 inch, so we have selected 2 inch pipes. In this 2 inch pipe size, we can go up to 10 number of sprinkler. So in this way, we have selected the pipe sizes for one branch line. In other side, we have only 2 sprinklers, so we will have the pipe size 1 inch. So you can see in this way we have selected the pipe sizes of one branch. Now we'll go for the main, because all branches are typical, so the pipe sizes will be same for all branches. But when we will go for the main, we will see after each addition of each branch, the number of sprinkler will be increasing. So for the first branch, we have the number of sprinkler 1, 2, 3, 4, 5, 6, 7, 8. We have 8 number of sprinkler in one branch, and we know from the table that up to 10 sprinkler we can use the pipe size 2 inch. So we will use the pipe size for the main in the end 2 inch. If we will add the another branch, so the number of sprinkler will be 16. Let us see from the table for 16 what pipe we need. You can see from the table up to 20 number of sprinkler we need the pipe size 2.5 inch. So for the 16 number of sprinkler we will use the pipe size 2.5 inch. Then we will add the 3 branches. So the total number of sprinkler will be 24, and we need to find from the table for the 24 number of sprinkler what is the pipe size. So we can see from this table from 20 up to 40 we need to use the pipe size of 3 inch. We will apply it on our layout. So for 24 number of sprinkler we need to use the pipe size of 3 inch. Then when we add the 4 branches the number of sprinkler will be 32. Again it is less than 40, so we will use the branch size of 30. When we will add the number 5, so it will be exactly 40, and we have seen from the table that up to 40 sprinkler we can use the branch size of 3 inch. When we will add the 6th branch the number of sprinkler will be 48, so we need to find the branch pipe size for the sprinkler total number of sprinkler. We can see from this table from 40 up to 65 we can use the pipe size 3.5 inch. For total number of sprinkler 48 we have selected the pipe size 3.5 inch. Then when we will add another branch, so the total number of sprinkler will be 56. It is less than 60, so we will use the same pipe size 3.5 inch. So you have seen in this way we can select the pipe sizing using pipe schedule method of NFPA 13. First we have make the calculation for find the location or for placing the sprinkler in the room. Before we make this calculation for remote area of 1500 square feet as per recommended by NFPA, then we generalize this study to our project, and we make the construction line accordingly, and we located our sprinkler. Then after this, using pipe schedule method of NFPA 13, we have selected the pipe size. So as I told you, this method is very easy and can be done manually, but the limitation is that we can use this method only for a small project and only for light and medium hazard. So I think I try to make this history with very explanation, very easy and simple, using the example, easy to understand. So I hope it is clear. Our next study will be design of a sprinkler system using hydraulic calculation. It covers the whole scope of a sprinkler system. Thank you very much.